Hey, I made
Alright, we're gonna have chocolate here.
Okay, so we're gonna finish 9.5, and before we sketch this next one, whenever you want to find intersection points of polar graphs, you know in rectangular, how would you find where they intersected with rectangular? What would you do with the two equations? Set them equal, and you would find all of them. Well, in polar, you may not find all of the intersection points, because remember, points are not unique, and you could have different theta values to still give me a same point. Does that make sense? So I will find some of them, but I may not find all of the points of intersection when I set them equal. Okay? So in order to find all of them, you need to sketch the graphs, or you may not see all the places where they intersect. Tell your neighbors that. Okay, so picking up from yesterday, let's see if you can get those two curves sketched on the same coordinate plane. Alright, so get them sketched. Think about all the stuff we did yesterday on the same coordinate plane. And also, you still want to, the newer part here is to set them equal to find some of the thetas where they intersect. And sketching will help you find the rest. So things you should be thinking about are the possible tangents at pole, an R theta chart, and intersection points, or intersection theta values, I guess, in this case. So you may not find all by setting equal, but you will find some. Probably most. So those are some things you should be thinking about as you're sketching these curves. So one of them is going to be what kind of graph? A circle, and the other one's going to be a. Go there yet? Does this one have a loop? IMAC with that squiggly ONS. Are you ready? Right, when they're equal, it's a heart. When A is A over B is less than 1, it's a loop. And vice versa, it's water. Yeah. Remember, as you're plotting those, it's beneficial if you put your theta values that they're equal to as you plot. So theta equals 0 straight and around the circle. Over here, right? It's going this way. Theta equals pi over 2. There, right? This one was theta equals pi over 4. Theta equals 3 pi over 4. At pi, you were already done with one loop of the circle. Is that okay? So I would always kind of put those values as I graph, because it will help. There's a tricky little component to this if you don't. You'll probably make this mistake if you don't put those theta values. help on any of those. Equal now. Can we talk about that in a second? Once you guys kind of get all of this, yeah. Just to make sure everybody can get those graphs first. Yeah, we should highlight possible helps with symmetry, so loops or anything. See how you just got one, so you kind of have a loop. You get two, then you can get a loop. Okay. And just having one, there's not going to have loops going on. Yes. So get a bigger heart. How are you guys over here? Values okay? Are we okay here? Okay. So we're playing this one. Very good. They do, right? Equal but you still have so it's still equal. So you can get some. So when you set them equal, say if you got these 2 pi over 3 and 4 pi over 3. Okay? So that's the other part that's going to help you. Is everybody roughly here? Okay, so now when I found those setting equal, what is that helping me with? Where are those values at? Well, right here, what fade is that going to be? 2 pi over 3. And the other place where they're intersecting right here is what theta value? 4 pi over 3. Now, which one did you not find when you set them equal? The pole. So there's another place where they're intersecting. See how they're intersecting at different theta values? One was at 0, one was at pi over 2. But at the coordinate point 0, 0, they're still, and that rectangular point, 0, 0, they're still intersecting. Okay? You just didn't find the theta values that overlapped. Does that make sense? Okay? But you still wanted those two theta values to help you with the other two overlapping. Yes? Uh-huh.
How would we show that the pole is also where they intersect?
Graph. Uh-huh.
I just listed like your uh-huh. So you should have worked to find these other two.
Okay, so is everybody there? Does everybody have this graph? Feel good with the graph set up? So now let's do what the question asked. So now the question says, find the area of the region in common to the two regions bounded. So where's the region in common? Is it out here? Now what am I following to get the sectors for where they're in common starting here? And sweeping counterclockwise. Okay, so I'm following this circle, right? Then at this point of intersection, what am I going to follow? The heart, the heart, the heart, the heart, then the circle, 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 circle. And I will find all of those, that value right like that, right? So as I'm following along to set up my integration of the area, where am I going to start on? The circle or the heart? The circle. What theta value is that? Is it 0? No. What theta value is that of the circle? Pi over 2. This is the tricky part right there. Because on the circle, that's why I made mine 2 different colors. And if you want to use colors, go for it, okay? It's kind of keep you organized. But right there, the circle is my green, and that was at a theta value pi over 2. At 0, I was over here. So I'm following the circle starting at pi over 2, going till when? 2 pi over 3. And I'm doing that for the circle, which was what? Negative 6 cosine theta squared, 1/2, right? D theta. Then I'm going to switch following the circle, and I start following the heart. Where am I starting on the heart at? 2 pi over 3. Until when? We could go all the way here, or we could stop right here and do what with those 2 things? Double them. I would like to do that. It'd make life a lot easier, right? So I could stop at pi, do it by 2 on both of these things. Okay. And on this one, I'm following the heart. And there we go. Will that give me the whole area of what they have in common?
Should.
Yes. And you can put that in your calculators now. Yeah. I wouldn't recommend it. Always look for symmetries. Sometimes tangents help with symmetrical, sometimes they're just tangents and poles, sometimes they help with loops, sometimes. Okay? Not always. Sometimes they are, sometimes they're helping with loops, sometimes just... Well, if they're a tangent at the pole, then they're not gonna probably... So you just gotta practice. Okay, so we're looking at what they have in common. So now, what am I following on that page? What am I following? Does everybody have a big heart? You have a big heart in this class. Skinny hearts will get deducted. Grinch hearts. No Grinch hearts. And let me write up the answer for you. Well, I just want you to be able to do that. That's just... So if you get it, you can check. It's 5 pi. So that's why. It goes back to the area of the sector. So if you're just sitting there waiting, you got it in your calculator, you can do a couple on your homework because we're going to make sure everybody can put this on their calculator. Okay, so if you're just sitting there waiting, you can always do something like that, okay? But I want to make sure everybody can get it in their calculator. We'll wait for you. No, I have that.
Here you go, the shot.
5 push-ups if you miss. 2 points on the second test if you made it. Yeah. Whistle. Oh!
I didn't even see the video.
Yeah.
Oh, it is.
Laughing alcoholic. Yeah, Elaine was in here early making sure he was closing. You put in the extra effort, I'll help you out. Did everybody get this? Did everybody get those? Really? I read chapter where it's actually. You want your flower? Like,
I cleared it
the
all.
water's poured. I swear to God, too, if you guys just had a little question on your No, why did you say that?
If we don't, that's one thing. I know it's not all one.
Yeah.
What about the mouth? The mouth. I can make it Yeah.
James, tell everybody what arc length for a rectangular is.
The integral of the square root of 1 plus f prime of x squared.
The
Dx.
okay. Now tell your group what the arc length of her metric is. Here you say this is C's. Alright, let's tell everybody that formula.
The integral of the square root of dx squared plus dy squared.
Alright. So,
From out.
now you get to learn it for polar.
Are you kidding me?
Alright. So with polar, what you're going to do is you're going to take your r squared plus your r prime squared.
What is R prime here?
R prime is not the derivative like with slope.
Okay.
Okay? R prime does other things, which we talked about. Okay, it helps check for tangents at the pole, and it's in this formula, but it's not the derivative of the slope. Alright, so now this is our formula for the arc length of a polar curve. So let's find the length of the curve over this interval for r equals 2a cosine theta. Then you can set it up.
Yeah.
We're going from where to where? Okay. Well, you don't know if it's symmetrical. You have to see. You have to check with the graph.
That was a good idea though.
It is a good idea.
That's just me sorry.
Alright, so now we always have a radical, right? We're always going to have a plus in the middle. So what are we going to put on this first squared and this first squared, and we're in what, d beta here? So this one's 2a cosine theta squared. You just plug in your r. And then what's the derivative? What's r prime here? Negative 2a sine theta. A. So now do this one by hand. It shouldn't take you very long. I decided to shoot it down. I thought it was a great idea, but you can't research. You know what that graph is. Did everybody get it to reduce to 2a d theta? And then that becomes what? 2a theta from negative pi over 2 pi over 2. I'm fine either way. And if you got that, try the next one with your group members. So this will help you out. Saying, feel this confidence back in your idea. Next one. Okay, so Okay, so you're d theta, right? So it's like saying all you had was just 2, and it was dx, and the answer was 2x. So now you're in theta, so it's like 2 theta, but you also have the a. It was just like square root of 2. Ooh. Shane's gonna get his confidence back here.
No, but what if it wasn't?
Then you can't.
How would you do it?
Then you guys wrap it.
Oh.
Can I just slap you? I'll talk to you.
So try to do this one quickly. Try to do this next one quickly. Don't take a lot of time with your graph. Try to get it going. I know. Because on this one, I'm not looking at your graph. So get a sketch, not a graph. Okay? So on this one, I'm not too concerned about where your heart's thickness is, because you're just going to be doing the arc length, okay? You're not finding any intersection points. You're not doing anything complicated. Get a rough sketch. Okay. Are we done sketching?
Yeah.
Almost? Okay, good.
Yes. Yeah.
Oh, that was horrible. That's a lot better. So you can put this one into your calculator for the integration.
So I was like,
And this is why, I'm pretty sure this one is why you would always want to have 2 calculators on your AP test. I think for some reason this one takes a really long time for your calculator to do. I think. I know there's a couple like that. So this is why you always want a couple of calculators, so as it's working, you can start on other things while you're waiting. Was it quick? Okay, well I know there's a couple like that, I can't remember. So this one was quicker, but I know there's a couple like that. Alright, so did everybody go from 0 to pi and double?
yeah.
Is that what everybody wanted to do? Okay. Wait, so I was wrong. I can't remember which one's taken, but I know. Booyah! Here, I'll help you take it.
Oh, yeah. Where did I get?
I forgot to.
So a question like this could be on a multiple choice because it's quicker, it's easier. So do you see why you don't want to spend a lot of time making the graph perfect if it's a multiple choice question? Okay.
Could you, like, would it be bad if you just called that, like, you choose
You might.
The only thing with graphing is to know your theta values. And even if this was on a calculator section and you could like put it into your y equals and get to heart, like I would still make a quick sketch of where my theta values kind of fall so I know where to set it up so that you're understanding where it's created from. Because it may not always like go out to 2 pi. It may have pi as one rotation, right? So that's why you kind of want to get those theta values to see. That's why we spend so much time so you don't mess up those little details. Okay? One more page of notes. Deep breath in, deep breath out. One more page of notes. So after we find arc length, what do we always like to do? Yeah, rotate it and get the surface area. Okay, so the way that they're... Hey, Flower Power, are you okay over there?
Yeah, we're just making some kettle jokes.
Okay. Alright, so surface area, you're still going to have your 2 pi r arc length, just like before. So we have our 2 pi, this whole thing is your r, and then you have your arc length, right? Now it gets a little bit more complicated with polar. They're going to tell you about the polar axis. So they're just meaning about this axis right here, 0. So if you're rotating this way, Blake, is your radius an x or a y? Right here. It's a y value. Right? Is that okay? Okay, so it's a y. Well, what is y in polar equivalent to? R sine theta. Oh, look at this. R sine theta. So all they're doing is putting a y here for the radius, but you have to write y in polar format. Yes, no, maybe? Okay. So here, if I'm rotating it about the line pi over 2, my radius is going to be a what? An x or a y? An x. An x equals what in polar? R cosine. And hey, there it is. R cosine theta. So you still have all the components, 2 pi r arc length. You just have to determine is r an x or a y and get it in terms of polar. See if anybody in your group has questions. Okay. So let's look at this one. Does anybody know what kind of graph this is going to be? What's r squared? R squared is a infinity sign. Okay? That sounds right.
Yeah, it's on the page.
Yeah. Alright. So we're going to be graphing an infinity sign going on. Let's get a rough sketch. Go. And you guys love graphing polar. Just love it. Well, same thing. So, yeah. Okay. Get your sketch.
Sketch or graph?
That's a sketch. It's not imaginary. I was just filling in the rest of what the graph is.
Now, what do we do?
It only asks from 0 to pi over 4, right?
Oh.
And then I just kind of dotted in what the rest would look like. Huh? Yes. be putting it all in. You can put this one into your calculator as well. So all of that's your R value. That's your radius. Then we have our R. And you might try to like simplify it a little bit before you put it into calculator so you're not typing so much. Plus, let's see, what's the derivative of this we have? So, R prime, let's rewrite that. So R prime, we're going to have to use our chain rule. 1/2 cosine of 2 theta to the negative 1/2 times negative sine of 2 theta times because we're dividing, integrate, times 2. So those guys will cancel, right? So let's see, I have negative sine 2 theta over cosine 2 theta. D theta. Try diamond enter. Make sure you have like all of the same like theta or x or something like that. Like all. Did you get it all? Yeah. If everybody in your group gets that, then you can try the last one with your group members. So if you're just waiting for your calculator, see if you can set up the next one. Alright, I have both up there so you can see. It should. Drum roll. When you look first, don't forget your D theta here. And this is fine as long as you have R prime. If you don't have R prime.
What? Sorry.
Did y'all do it? Okay. Start setting up the next one. Really?
And it says may not be fully simplified.
This for that.
Got it. So cute. And I forget it. I got it.
Might just start over. So like if you write it, see it's called like that. Like set it like that. Okay, let me find that. Okay, go back. I read it. You got it? Sorry guys. Now the good news is too, a lot of times if this was a free response, they would just say what's the correct setup. Okay. A lot of times they would do that. But sometimes you have to put it in the calculator, so you do want that skill of being able to use the calculator. Just gonna put the answer to this one if you are working on that as well. A is just a constant. It will be put it into your so you could make it just like A. Yeah, just put A's.
It's not a,
Well, I didn't.
great.
Well, you didn't multiply by 2 pi at the
Yeah,
beginning.
yeah, you know what? I
So let's do times 2 pi. Okay, do it again.
Do we just revolve the whole? I think they can. Always just
And you're counting next to finish that. Yes. Now put it in your calculator. Do it. Okay.
The problem is I put it in one.
Little right.
you're gonna kind of create
Let's go.
Just go like a.
Huh? And make sure you put the multiplication sign. You can clear your variables there. I never store in this calculator very much. I always store in my 84. So if you go to cleanup, hit F3, go over to S6, and hit R8. There you go.
Oh man.
Yes. Now put it, I put it right in.
Okay. Cool, that works. Was it just a yeah. Okay, it probably forgot I'm also the same here. You guys get it? Calculators? Yeah. Yes. It'd be so good.
All right, how are we doing? Are we all there?
So you gonna bring this for us?
Hopefully it will make it run for the future.
You have to have channels with your name. All of them.
I don't have it, Jerry.
Lost it.
Hold on.
No, I got mine to do it. There you don't have a beat. I'm gonna have to chat some off. Yes, please. Okay, so I think you all have the same right setup. If you're just putting it in the calculator, you can finish. Here's your little joke. I know it's kind of long, but I think it's really funny. Okay.
Well,
So, let me just. 4 friends have been doing really well in their calculus class. They have been getting top grades for their homework and the midterm. So when it's time for the final, they decide not to study on the weekend before, but drive to another friend's birthday party in another city. Even though the exam is scheduled for Monday morning, as it happens, they drink too much at the party, and on Monday morning, they are all hungover and oversleep. When they finally arrive on campus, the exam is already over. They go to the professor's office and offer him an explanation. We went to our friend's birthday party, and when we were driving back home very early Monday morning, we suddenly had a flat tire. We had no spare, and since we were driving on back roads, it took hours until we got help. The professor nods sympathetically and says, "I see that was not your fault. I will allow you to make up the most exam tomorrow morning." When they arrive early on Tuesday morning, the students are put by the professor in a large lecture hall and are all seated far apart from each other. Other than that, even if they tried, they had no chance to cheat. The exam booklets are already in place, and confidentially, the students start writing. The first question, 5 points out of 100, is a simple exercise in differentiation, and all 4 finish within 10 minutes. When the first of them has completed the problem, he turns over the page in the exam booklet and reads the next one. Problem 2, 95 points out of 100. Which tire went flat? I know, I loved it. Anyway, it's not really a joke, it's just kind of funny. Huh? Yeah. So, there you go. And we are not going to do 9.6. If you want to learn more about Kepler's law and different things, you can study it on your own. But we are down with chapter 9.